Hello, everybody. It's me again, Rich Andre, or Andre, and I'm going to be showing you how to solve for eigenvalues. And this is probably going to be very advanced um, because, for the sole reason that this topic is mostly for college students and our first year college students, and a lot of them from my own observation, they're struggling with this topic, with finding eigenvalues. And today I'm going to show you, or at least walk you through, a few simple examples of how to find eigenvalues in 2 by 2 matrices. Okay, so let's start with the first uh, example. Let's say we have a matrix, 2 by 2 matrix, which looks like this. Okay, we got 2 0 0 5. Okay, so in order to get the eigenvalue of this matrix, you simply have to multiply it multiply this first diagonal right here with lambda. Okay, so this will look like this, I believe. um, in order to get the eigenvalue, you will simply have to do this: a minus lambda and times the identity. Okay, but before we try to find the eigenvalue, you simply have to compute for the determinant, for what we call the determinant of the matrix first. So this will go like this. Okay, first you have to multiply the first diagonal, then the second diagonal, and then simply just subtract first and the second diagonal of each other. So you will have, in order to compute for the determinant, it's basically just, okay, let's say determinant A, try to find a matrix for the matrix A. If I'm trying to find the determinant for matrix A, will be notated like this. I don't really need to copy and paste the numbers right here because it's a little bit redundant. So I'm just going to notate it as that. So we have determinant A, and then A D minus B C. And for this, we just have to substitute the numbers. Okay, so we have 2 times 5 minus 0 times 0. So we can just completely disregard this one because it's just equals 0. So we have 2 times 5, which is 10. So the determinant is 10. Okay, the determinant is 10. Okay, so now we just have to use this. Just have to use the you just have to find the eigenvalues now. To find the eigenvalues, you simply have to subtract lambda to the first diagonal of the matrix. Once you get that, okay, you simply have to, I believe, I'm sorry, this wasn't actually the determinant. Okay, you don't need to find a determinant for the matrix. You just simply have to find a determinant after you subtract the lambda. So we have here AD minus BC. Okay. So we just have to times this. You have 2, then 5 lambda, 5 minus lambda. Then we have to subtract with 0, okay? Because 0 times 0 is basically just 0. So now we have to factor these two parentheses right here. Oh, no. Sorry. We actually have to FOIL method these two parentheses. So we have to go with FOIL method first. So 2 times 5 plus 5 is 10. Okay. So you just have to 2 times negative lambda is 2 lambda, negative 2 lambda. Okay. Then we have to multiply negative lambda with negative 5. Sorry about that. And multiply the last ones. So negative lambda times negative lambda is negative lambda squared. So we're just going to arrange that with the order of exponents. We have 8 lambda squared. Yeah, 5 lambda, negative 5 lambda, negative 2 lambda, and positive 10. So now combine the like terms. So we have negative 3 lambda plus 10 and lambda squared. So now we have to find and factor these two numbers. So what multiplies to 10 and adds up to negative 3. Okay. We just see if this is correct. Just trying to see if this is actually correct. Oh, I'm sorry about that. Sorry. It's actually a wrong answer. It's actually 7. Okay. So you have 7, negative 7, and positive 10. We have positive 10 right here. Okay. So what adds up to 10? No, sorry. What multiplies to 10 but adds up to negative 7? Okay. But it adds up to negative 7. Our factors would be x. I believe it's negative 5, negative 2. Okay. X and negative 2. So you just have to set these to 0. Okay. Then you'll find the eigenvectors, okay? So I have to transpose this, okay? Just have to transpose -5, and we got positive 5x and positive 2. And this is going to be the eigenvalues for our matrix right here, okay? For our A matrix. So you could probably see what I'm going with this, where I'm going with this. Let's try another one. Let's try another example right here. We're just going to try out 3 examples. And that'll be the extent of it. Okay. So we have 4, 0, then 0, -1. Then we have the it's going to be the last example that I'm going to use. Let's solve this. Okay. Simply have to, in order to get the eigenvalues, you just have to do the same thing as you did earlier. The first number. Let's leave it as the first number. So you just have to minus that. We got. Okay. So afterwards, you just have to times both of them. Yeah. 4. We could just completely disregard the zeros because that you don't really need them. This is going to be very redundant if you have to consider the zeros. Okay. So you just have to FOIL method again. Okay. So 4 times -1 is -4. 4 times negative lambda is just 4, -4 lambda. Okay. Negative lambda times -1 is going to be positive lambda. Very sorry for that. So we have to, let's go back to where we left off. This is the last. Okay. So negative lambda times negative lambda is positive lambda. So we're going to just rearrange that. Okay. So we have negative positive -4. How big that is? -4. If I'm correct. Okay. So now we just have lambda and I believe it is lambda. So 1. Let's just skip this number for now. Let's go here. Fortunately, I can't really solve these today. So I'm just going to do this in a part 2 of this video. But I hope the first example that I did carefully demonstrated what finding eigenvalues are. So I hope you learned something from today.